Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about this common source amplifier with diode connected load. We already discussed the common source amplifier and calculated the gain of this amplifier by using small signal model, but in the end I told you, with some sort of inspection you can see through different nodes of this amplifier and said what is the gain. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. This is the common source amplifier, and if you already seen my previous videos, this is a basic common source amplifier with load resistance RD. This is grounded and this is V in, and here this is V out. Just to remind you, I told you the AV or V out divided by V in for this amplifier is going to be the negative sign, the resistance seen from the output, which is R out for this amplifier. By neglecting channel length modulation, you can only see RD divided by the resistance seen from source to the gate, when in this case the input voltage has to be grounded. When I look at through it to calculate the resistance, what was this resistance? If you remind it, please let me know in the comment section. This is going to be helpful for you guys to be active while you're watching these videos. This one was 1 divided by GM. So here this is 1 divided by GM, and the whole gain of this amplifier is negative GM times RD. Now how about this amplifier? I'm going to use this calculation and apply it into this amplifier. For this one here, I can simplify this. Let me change the color. I can simplify this. M1 is M1, no problem with that. How about M2? How can I simplify this? Well, M2, if you all remember, in another video I told you this is a diode connected device, and we convert the 3-port device into 2 ports. So you can simplify this by using this resistance with 1 divided by its GM, which is GM2. There was a simple improvement for this, and I use it a lot actually. So try to keep that in your mind. I replace M2 with resistance with the value of 1 divided by GM2. Now what is the gain for this amplifier? V out divided by V in. Again, the negative sign is still there, and I can use this formula in the end, negative sign for GM, or I can use it from the beginning. This is the fraction. What is the resistance from the output? From the output you can see just 1 divided by GM2, and here again the resistance seen from source through the device when the input is short circuited to the ground is 1 divided by GM1. Try to use that subscript because there is 2 different transistors. So the gain would be negative sign by some simple mathematics minus GM1 divided by GM2. This is the final gain of this amplifier. Now let me just try to use some numerical examples to get the better feeling about this amplifier. The gain is not that much. The gain is not that much compared to the previous version, which was a load resistance, but the dependency of the current is eliminated in this scenario. Here you are dependent to the bias current of the circuit, but here the dependency of current is completely eliminated. So here, this is a simple problem. To have a better feelings, we had to determine the value for W over L2 for a voltage gain of 2. So here, this is a voltage gain, the absolute value, so forget the negative sign, GM1 divided by GM2. As you already know, we have 3 different formulas for GM, and it is better to use the square root. What is GM1? Square root of 2 mu n CO oxide W over L1 I drain 1. And what is the formula for GM2? Again, square root of 2 mu n CO oxide W over L2 I drain 2. If you look at the circuit, you can see that this is the I drain 1 here, and this is I drain 2. So both I drains of these transistors are just the same. You can get rid of it. And these two together are mu n CO oxide, mu n CO oxide. So you have left with square root of, this is the simplified version of gain of this amplifier, square root of W over L1 divided by W over L2. So the absolute value of gain equals to 2. And now we can calculate this W over L2 by taking the power of 2 for both sides of these equations. Let me just use it in here. Take both sides to the power of 2. Here we have W over L1 divided by W over L2 equals to 2 to the power of 2, which is 4. Now you can calculate W over L2, which is equal to W over L1 divided by 4. Here this one is 20 divided by 0.18 divided by 4, 20 divided by 4, which is 5 divided by 0.18. And this is the final result for W over L2. And by the way, the reference of this practice is from Fundamentals of Microelectronics by Behzad Razavi. I just for the sake of simplicity just change some numbers. That's it. That's it. What the main problem was there. Okay, I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. See you on the next video.